Right. Good. Solution. Now, what we are asked to evaluate is the domain of g of f of x. You cannot jump into getting the domain of this guy again, it is not done. You must know the composite function value of g of f of x. Are you getting me, right? When you get it, before you can now evaluate the domain. So let's be fast in English. Are we ready? You are asked to evaluate g of f of x. What do you do? Go to the function called what? G. Anywhere you see x there, you fix what? F of x. Is that not so? Once again, I repeat. You are to get the domain of g of f of x. The first thing you have to do is to get the function called what? G of f of x. And that is a composite function. Are you getting me right? And how do you get the function called g of f of x? Go to the given function g. What is the function called g here? How was it defined? Square root of what? X plus 5. So you are going to go to that guy, that function called g. Anywhere you see x, you put what? F of x. Remember, f of x has a function defining it. True or false? What is defining f of x? What is f of x given to us? X squared plus 1. Is that not so? So this thing, let me reinterpret it. It means go to g. Anywhere you see x in g, fix f of x. And what is f of x as given in the question? X squared plus 1. So in place of this f of x, I am fixing what? X squared plus 1. So automatically, this thing is telling us, okay, you know g of x. Are you getting me right? Go to that g of x. Wherever you see x, kick it off. Substitute. Fix. Replace. Put. X squared plus what? Do you understand that? Any question on the interpretation? Do you understand that? You don't understand? Are you ready? I want to explain again. We were asked to evaluate the domain of g of f of x. Is that not so? Right? And I am telling you, you cannot get the domain of g of f of x directly from this. Do you get that right? Because it is not the domain of g they say you should find. It is not the domain of f of x they say you should find. It is the domain of these guys put together. Are you getting me right? So the first thing you do is to evaluate, solve, get g of f of x. And so I try to interpret the meaning of g of f of x. Are you getting me right? Just like somebody telling you find g of 2. What is the meaning of g of 2? Go to the function called g. Anywhere you see x, you put what? Now. Am I communicating? The same thing. The fact that it's not known by you have here does not change anything. Are you getting me? Follow the same protocol, process, method. G of something. The something is no longer a number. That something is what? F of x. So what it means is go to the function called what? G. This is the function. Are you getting me? Any place you see x, you put what? F of x. Do you understand up to this point? But we now say, from our question, they have told us what f of x is. F of x is what? Given in the question. So somebody who tells me to go to G and fix f of x, are you getting me? Is still telling me the other way around. Are you getting me? Go to G and fix what f of x is, which is what? X squared plus 1. That is why I wrote it like this. That g of f of x means go to that function called what? G. Anywhere you see x there, remove that x and put, fix, substitute what f of x is. Are you getting me right? And that f of x is x squared plus 1. Do you understand the interpretation, right? Okay, now let us move on. Having understood this, we can now say this is equal to locate the function called g. Have you located it? Yes. Tell me the function, please. X plus 5. Square root of what? X plus 5. Are you there? Yes. Look at it. So anywhere you see x, you put what? x squared plus 1. Are you ready?
Yes.
Are you ready? So let us do that. This will be equal to this function. It is a radical function. In place of this x, fix x squared plus 1. X squared plus 1. Are you seeing it right? Then plus what? 5. Because you just substituted for this x. You are still left with plus 5 in that function called g. Are you getting me right? So plus 5. Therefore, g of f of x is equal to, simplify this. Are you getting me right? Open up the bracket. If you open up the bracket, you get x squared plus what? 6. Do you agree?
Yes.
Do you agree? Good. Square root x squared plus 6. So this is the function called g of what? F of x. Please take note. Suppose this x was squared, for example, or was raised to power 3, for example. Are you getting me? When you remove that x and fix x squared plus 1, are you getting? That whole x squared plus 1 will also carry that power.
Yes.
Which means you need to simplify this further. You get that? And that is if this had what? A power. It does not have power, so let's just forget about it. Now we have gotten the function called what? G of f of. This is dangerous. This is what?
Dangerous.
I wish I had tested this, because to get the domain of this guy is not possible. You know why?
6 is not a perfect square.
Is it?
6 is not a perfect square.
The 6 is not a perfect square, and apart from that, there is no square root of a negative number. Now that we know the function that is defined as what? G of f of x. I think no one has a problem here at this point. We can now get the domain. How do we get the domain? Go back to everything you learned about domain of those 3 functions I told you to be preparing yourself for. Rational, radical, and polynomial. Which one is this? Radical. How do you obtain the domain of a radical function? Set x squared plus 6 to be greater than or equal to what? 0. Now this is where I say there is going to be a problem. If I move this guy x squared, if I move this guy x squared to be greater than or equal to minus 6, is that not so? You can't take square root of that thing, true or false? You can't, so that's the problem. And on the base of that problem, I may wish to make some adjustments. I may wish to make some adjustment to this question. What if I had made this thing to be minus 5 so that our result, I'm trying to correct now, so that our result here will carry minus. Are you getting me right? When it moves, it becomes what? Plus. Then we can do that thing. Sorry, I didn't tell the question before. So it's still following the same process. If you come here, is that also? This sign will be what? Minus. I'm glad you understand that. Then, wow, this is perfect. This is perfect. Right? Because if you open up this bracket and solve 1 minus 5 will give you what? Minus 4, which actually gives us a difference of 2. Don't mind this for you, right? You know your exam, see, they test the question before they give you. Is that not so? Now. So, that's good. I love that. So this is x squared minus 4 greater than or equal to what? 0. We are going to use our shortcut to solve this, so I will take that last question. There's a particular question we have to solve before going, so we know we are done with composite function. What is the shortcut to solving this? First of all, you know that the answer of this will either be plus 2 or what? Minus 2. Because we find the square root of this, so we're going to get plus minus 2. Now, it's for you to know which one will carry greater than or equal to, and which one will carry what? Less than or equal to. Is that not so? That depends on the arrangement of this guy. Which one came first? Is it the alphabet square that came first or the number square?
The alphabet.
The alphabet square. Now look at what we said. For a problem like this, simply find the square root of this guy, 4. Square root of 4 will give you plus or what? Minus 2. Then, because this x square came first, that is the alphabet square came first. Are you getting me? It means that less than we go with the smaller value from here. Are you getting me? And greater than we go with the what? Bigger value. Let me ask you now. What if this thing was 4 minus x squared? Which one will carry less than? The bigger one. And which one will carry greater than? The smaller value. Is that okay? So from here, since x squared came first, it means we are going to get x less than or equal to plus 2 and minus 2. Which one is smaller? Minus 2. Or x is greater than or equal to plus 2 and minus 2. Which one is greater? Plus 2. So with this, we can put the domain. You see, if you are to draw the number line of this, which you don't need, is that not so? For this question, because we treated something like this yesterday. I guess the domain will go apart, something like this, is that not so? From minus 2 to negative infinity, from plus 2 to positive what? Infinity. Because this is telling you that the domain, are you there? Are all real numbers from minus 2 to negative infinity. Are you following? See this thing? The values here are from negative 2 down to negative what? Infinity. The values here are from what? Positive 2 down to positive infinity. Now you can quote the domain from here. We're going to quote it using special brackets. If we start from infinity, isn't it? Negative infinity and terminate here. Which bracket will you use here? Correct. Reason. Minus 2 is part. Are you getting me? Minus 2 is part of the domain. If you use this square bracket, it means this number is part of the domain. This thing, minus 2, is part of the answer. How do you know that? If you use curved bracket, it means that that thing that appeared before or after it is not part of the domain. Infinity is not a real number, so it can't be part of the domain. It's just a boundary for us here. Then watch, you will unite it. Because this thing you are seeing here, once you move from negative infinity and terminate at minus 2, do you continue with minus 1, 0, 1? Do you do that? This thing jump, there is a break. So it jumps to positive 2, is that not so? And positive 2 is part of the domain, so you open with square brackets and terminate where? And this is the answer. So do you see how you handle that, right? First of all, evaluate the composite function. Are you getting me? And then from whatever you see in the composite function, use the knowledge of what you learned on how to get what? Domain. That's it. Our last question is. That one is past question. Your friends have tried. And that's interesting. Alright, so we have this last question on 5, and then that one number 6. Like I said, I'll give you number 6 as an assignment. I'll give you a hint. That one is 1 plus 1. I choose to solve this one because of the 3 functions given to us, okay? So how do we handle it? Like I told you, composite function is all about substitution. So let us attack this question 5 first. Solution to question 5. Solution to question 5. 2018-2019 past question. Okay, so what we have there? We have to compute h of f of g of x. That's how it is read. H of f of g of x. I'm sorry I have to write it this way. Are you getting me right? It's still the same as using those brackets in the bracket. Now, how do we solve this problem? Are you ready to get the secrets? Solve from inside. Coming outward. That is, move from inside. Are you getting me right? And then you move outward. And if I express this thing like this, the inside is from the right hand side. Are you getting me right? Start moving from there and going to the what? Left. Do you understand that? Like in this case, we have to evaluate f of g of x first. Are you getting me right? Then anything we get as f of g of x, we will now go to h and do what? Fix it. That's the interpretation of this. Are we ready? So let's go. From inside, which is from this one, this is telling us, go to the function called f. Are you there? Wherever you see x there, fix what? G of x. Can you locate the function called f from the question given to us? 2x. 2x, is that not so? So we'll go to that 2x. In place of this x, we would replace it with g of x. But if you look at this question, we have g of x as a function, true or false? What is representing g of x in our question? X minus 5. Which actually means we go to f of x. Wherever we see x, we put what? So we'll substitute, we'll fix x minus what? 5. That is the first thing we do. Are you getting me right? So first, let us evaluate f of g of x. That's going to be equal to, where is my f of x? 2x. So I'm going to write 2. Are you getting? 2. Open bracket. Wherever I see x, I will fix the value of x. And the value of x is x minus what? If you simplify this, what would you get? Do you understand that, right? 2x minus 10 is now a new function that defines f of what? G of x. Is there any question? I hope it's clear, right? Now, the function continued that we should go to h, the function we call h. Anywhere we see x there, we should put all these things called f of g of what? X. Do you understand that, right? Go to the function called x. Go to the function called h. Wherever you see x, remove that x. Instead, fix what? F of g of x. Are you getting me right? And do we have the function that is defining f of g of x? Do we have it? Yes. What is defining f of g of x for us? That is correct. So let us visit the function called h. Are you there? Where is the function? Sin x. Are you getting me? Wherever we see that x, we will fix f of g of x. And that f of g of x happens to be what? 2x minus 10. So let's do that. Therefore, h of f of g of x is equal to, if you want to present it like this, they try to see us. Are you getting it? Locate h of x. Look at it. Sin x. Wherever you see x, fix f of g of x, which is this 2x minus 10. So let's go. Sin. Is that not so? This x, you remove it and fix what? The whole of f of g of x, which is? So you see, no matter how complex this thing looks like, is it very difficult? No. Everything being equal, this is actually simpler than this, to be honest. Yeah. It's simpler than that. It's just I don't want you to leave and not see this question down here. You see the 3 from there, how do we do that? So the correct option here is what? And the person that mentioned that earlier was correct. In conclusion, remember you are dealing with this as assignment, but this is the secret, okay? You were given that g of x minus 3 is equal to this function. The problem now is that this thing is not just g of x. Are you getting me? It is not just g of x. This function is not just g of x. This function is defined as g of what? X minus 3. Now your examiner says you should compute what? G of 0. What it means is this. If you are to compute g of 0, it means go to the function called g. Are you getting me right? In place of all these things, replace what? 0. That is anywhere you see x minus 3, you fix what? 0. But let me ask you please, are you ready? This function given to us, do you have any x minus 3 clearly written? Is there any factorization or whatever that brought out x minus 3 in this function? No. So that is a problem. That is what? A problem. The only thing you can substitute for here is what? The only thing you can fix the value for here is what? X. So the secret is this. Since the examiner says you should calculate or compute or get g of 0, it means go to this function called g. Anywhere you see this, you know, ordinarily on the ones we've been solving, this thing could have just been g of x. Is that not so? Now, so it doesn't change anything. Come to this guy, x minus 3. Wherever you see x minus 3, fix what? Now, if that is the case, we can actually say x minus 3 will be equal to what? Because we are replacing x minus 3 with what? 0. From there, get the value of what? And after getting the value of x, I think your problem is solved. Go to that function and then do what? Fix that value of x. That's how you handle it. Please ask the question as I leave this stage. Examiner tells you that, hey, this function I gave to you is not g of x. Are you getting me? It is g of x minus what? 3. But now, get me g of x. Sorry, get me g of what? 0. So the idea is, anywhere you see x minus 3, fix what? 0. But unfortunately, the main function definition, there is no x minus 3 there. Are you getting me? So you will capitalize on the fact that x minus 3 should be equal to 0. Are you getting me? Get the real value of x. So you can now substitute here. So that is it. Yep. Alright, so we'll be meeting God's willing, on Friday. Are you getting me right? By 3 o'clock to 6. Remember, that's our normal time. Hopefully tomorrow I'll still come to talk about our class. Possibly, I may and may not. That's just it. I may and may not. But our next class will be on Friday. On Friday, yeah, we'll finish everything left about function. Finish everything left about function. So that by Saturday we'll move on to differentiation. Please remember to talk about our tutorials, inform your friends, invite them to join us. Let's build this learning community that gives everyone the opportunity to try. Is that okay? Thank you very much for coming, and do have a wonderful day.